Hello everyone and welcome back to Adrian's Digital Basement. This is part 2 in my Improving the Commodore PET 2001 series. So if you haven't seen the first part, I recommend you go watch that first, as this is a continuation from that part. In the first video, I applied a permanent killer poke mod to my PET and showed how much faster the machine is with that mod installed. And then I talked about the spot that appears on the CRT of the Commodore PET when you first turn it off. And my friend Frank, IZ8DWF, talked about why that spot happens, and he devised a fix, which I applied to my PET, and it didn't work. So in this video, I go through all the troubleshooting steps to figure out why the spot fix didn't work on my PET, and then what I need to do to make it work. So without further ado, let's get right to it. So there's a better shot of the installed Zener diode and resistor, and yeah, it's not working. I've chatted with Frank a little bit about this, and he says most likely my problem is leaky and crappy Zener diode. I told him that I got these from, yeah, you know where, AliExpress, and he said, yep, that's probably the problem. He said while he was working on his monitors, he found that one of his Zeners also didn't work, but he swapped it with another one. He took out of a working monitor, and then that fixed it. So a few days have passed and I got a package from DigiKey. I ordered a nice assortment of Vishay, I think that's how you say it, Vishay branded Zener diodes. So these are actual good quality ones, unlike the Chinese ones. So let me break out the 8.2 volt, find it in this package here, install it, and then we can give it a try. So first off, I'm going to remove the old diode. Here's the packet of 8.2 volt diodes. Let's take a look. I haven't actually looked at these. They look pretty much identical to the ones I was using. So I'm just going to clip straight onto the diodes on this little package. In case it's not working, you know, these diodes are, well, they were only about 16 cents a piece, so they're very inexpensive. But if the fix doesn't work, I won't be cutting one of these off the packaging. I can just put it back in the bag for use on a different project. From a direction standpoint, the black band on the diode goes towards the top of the board here. So the red clip lead, which is clipped onto where the old Zener was, that goes to the side of the black band, and the black one goes onto the end of the resistor. I gave the scene a quick check over to make sure nothing was touching, no shorting, no tools, because it has been several days. Everything looks ready to go. Let me turn this on, make sure it actually shows an image. And we have no image, but there's a reason for that. And with my checking, I didn't even notice that the monitor wasn't even connected. Okay, everything is connected now. Here we go again. So I'll just let this warm up for a second. Actually, let me just check. Yep, the picture is nice and clear. It's nice and sharp. That is the cathode driver, that little combo that's in there. So for instance, if that clip lead weren't connected properly, we would have no image at all. Here we go, moment of truth, a good quality Zener diode. Are we going to have the dot or are we not going to have it? We still have the dot. Okay, so on recommendation of Frank, I have removed Q1 here, which is an old Motorola part 2369, and I'm installing a new transistor. This is a BC548B. It's not an ideal replacement, and I'm using my desoldering iron to solder because that just happens to be what I have handy. All right, the part is now connected. It is turned 180 degrees versus the original because this is CBE and the original was EBC, emitter base collector. So you just have to take note of that if you're trying to replace one with another. The new diode is still connected, so I'm going to leave that like that. All right, moment of truth. Will this even work? Hopefully we get a picture. We'll be ready to turn this off in case there's a problem. Oh, it looks like crap. Okay, so that's obviously not a good transistor. Well, let's see if at least it has the dot. Here we go. And there's still a dot. So it not only looks like crap, but like, look at that picture quality. It's horrible, but it didn't even change the dot either. So people might have noticed that I have this little potentiometer stuck on the bottom of the board right here. And what this is a focus potentiometer that I've installed because this board normally doesn't have one. It just grounds the focus grid, and this allows you to take focus grid up to about 85 volts. I found there was very little effect with this, although turning it all the way up to 85 volts seemed to help. But Frank just let me know that he thinks that this might be causing the issue. I'm going to quickly swap back in the original transistor, and I'm going to take this potentiometer out. All right, let's turn it on. I expect the picture quality to be back to normal. Yep, okay, that looks really good. Remember, I have the Vishay diode still clipped in. Frank was racking his brain trying to figure out where this extra current was coming from because we tried a different transistor, we tried the good diode. It just didn't make sense to him. And then he realized that I had installed this potentiometer. This is optional. The service manual does say you can use this, but it doesn't necessarily help. And he has found that he has not had good luck on his monitors. And sure enough, when I installed it, I saw maybe the tiniest of improvement when this was installed and I had it turned up, giving 85 volts to the focus grid. But he thought that this could allow the current to leak through to the cathode driver, causing the dot when you turn it off. So let's see, with that removed, and I put it back to stock configuration where the grid G4 is grounded again. Here we go. What's going to happen? Oh my God. No spot. No freaking spot. That fixed it. This was causing the dot. Now, of course, the dot's there in the stock configuration, but, you know, I had added this trying to fix a different problem. And all of these fixes for the spot were being thwarted by this. Oh. Okay, one more try. Look at that. Look at that. Wait, there's a spot now. How crazy is that? That's interesting. It's super, super delayed now. Let's turn this back on and I'll give you a closer look. I have the focus and exposure locked and everything is adjusted, so you should get a good view of any spot that we get. So let's look at this in real time. I'll turn it off. And we would have seen that spot by now, right? But we just wait and we wait. And look at that. Look at that. A little spot has appeared. Now it's really, really dim, which is good because my biggest concern wasn't so much that there was a spot, more so that I was concerned that it was going to burn a hole in the phosphor, especially, you know, power cycling the machine off and on. The computer's been running for about 15 minutes. Let's just see what the dot looks like here. See if it's brighter, dimmer. Okay, that's actually pretty bright. It's not nearly as bright as the previous dot, but interesting how it brightened up. So talking to Frank, again, I'm chatting with him during making this video. He doesn't think that this is related to the Zener anymore. He thinks there's a different problem on this board that's causing leakage. So remember that adjustment pot for the focus, that was leaking current, that was causing the dot. The original design had the leaky current, which is why the dot was there. It's still doing it. So something else on this board is leaking. Now, incidentally, you may have noticed originally the board was really dirty, and then later that section where the cathode drive circuit is cleaner. I ended up cleaning it with isopropyl alcohol and letting it dry overnight just in case any of that dust on there was a problem. But apparently not, because that had no effect at all. Well, that was while the focus pot was on there. But taking that focus pot off did at least delay it. And the dot, which still gets kind of bright when the machine is on for a long time, it's way less bright. You don't see all that sort of blooming and diffraction around the spot in the phosphor. So I'm imagining that this is a bit better of a situation for this CRT than it was, at least, even if I'm not able to exactly figure out where that leakage is coming from. To help with the process of elimination, I had the thought to use a different CRT to see if we got the spot on this on turnoff. If we do get the spot, then that surely tells us that there is still a problem on the PCB. But if there's no spot, then that definitely points to a fault in the original PET monitor. This is a CRT out of a Macintosh, and it's close enough to the PET CRT that it should absolutely work fine with this analog board. Let's give it a try. Turn it on. And there it is. We have an image. Ignore the fact that it's a little crooked. That's just because I had the deflection yoke just loosely put on there. It's not aligned properly. Okay, so let's let this warm up a moment, and then I'll power it off, and we'll see if we get a spot. All right, moment of truth, spot or no spot. And I've been watching this carefully for about a minute, and there's absolutely no spot. So I think that pretty much clinches it that it's the CRT in the PET that has a fault now that's causing that spot. There were multiple problems, right? There was the original problem on the board causing the spot, but now we have some slight leakage in the CRT, and that this CRT has no issue. Now, unfortunately, I can't just install this CRT into the PET, and that's because these mounting tabs on the implosion band here are in a different configuration. On the Macintosh, they are mounted towards the front of the implosion band, and on the PET, they're mounted towards the back. So if I tried to install this CRT in the PET, it would be set back about 1 inch in the case. There would be a big gap. So clearly, that's not going to work. I have the original CRT connected, and of course, there'll still be the 15-second delay dot on this thing. Yep, there it is. There's pretty much one final test we can do to confirm that this CRT has current leakage between the heater and the cathode, and that is to use my benchtop power supply to power up the filament, that's the heater, on this CRT and disconnect that from this PCB back here. This particular analog board powers the heater on the CRT from the same 12-volt power supply as the rest of the board. So it is all connected together, meaning any kind of current leakage in the CRT could allow that cathode a path to ground. My bench power supply is a linear isolated type, which means that its positive and negative DC output is not referenced to earth main, as is the power supply in the PET. So if I power the filament from that, there is no return path from this power supply back to this power supply. They are completely isolated. These are the two filament heater wires. There's E2 and E3. E3 comes from the board right about there, and this one here, E2, comes from the board up there. So I'm just going to clip on my power supply here, and we'll test powering up the filament from the bench power supply just to make sure that it lights up with everything turned off. While the filament is connected to 12 volts on this power supply, it actually has an 8.2 ohm resistor on it, so it probably runs more around 11 because it's a bit current limited. So I'm going to run this at 11, and I'll just turn up the current. First we'll start at 500 milliamps. Here we go. And if you look through the wires there, there's that glow of the filament. It's using about 132 milliamps at 11 volts. All right, let's turn on the PET here. Look how it was instantly on, and that's because, of course, the CRT filament was already warmed up. Sort of similar to those old TVs back in the day that had instant on. I had one of those growing up. It was a color TV in our living room, I think made by Quasar. It was probably made in the very late 70s, and when you turned that thing on, it basically was on instantaneously. What those did is they would run the filament all the time, even when the set was off, probably at a lesser voltage, but that way when you turned it on, it was pretty much ready to go. But it would have the effect of wearing out your CRT even when it was turned off. So not really desirable. Just for fun, I'm going to turn off this power supply while it's on, and you'll see what happens to the image. It's off right now. And look how it's very slowly fading. And this is what allows that dot to stay visible there. As you saw with the very gradual fade out, even when the voltage is removed, there are still electrons ready to be shot towards the front of the screen to create an image or a dot in the center. Let's do the final definitive test. If I turn this off and there is a dot, that tells us that the current leakage is happening on the PCB. If I turn this off and there is no dot, that tells us the current leakage is happening inside the CRT itself, and there's no way to fix that. Here we go. We still have the dots. So that tells us that it's actually still the PCB, and it is not the CRT. Wow, let's turn it back on. You'll notice the instant on picture. Look at that, instant on. So this video has really been a bit of a wild goose chase because every time I thought there was a problem in one place, it was somewhere else. And I thought the CRT was the problem and the Mac one worked, but now this is pretty much confirmed with the bench supply that the problem is probably not this CRT, and it is actually this board. Although maybe the leakage is happening between the cathode and one of the grids. I mean, that's potentially possible. They're just not close to each other inside the neck. Physically, they're far apart from each other. So that seems a little unlikely. So this testing, once again, points back to this analog board as the source of the spot. Oh. Well, fast forward a few weeks from that last segment you just saw in this video, I now have two PETs. Now, these aren't both mine. This one here is with the blue screen. This is the one you've been seeing me work on. This PET here actually belongs to Earl Evans, and he lent it to me for this video to help me troubleshoot what's going on here. Now, even though these are both 2001s, obviously there's some differences. Mine has the chiclet keyboard and the tape drive built in. His has the more modern keyboard and, of course, a black bezel. And that's because this is one of the later 2001s that Commodore quickly replaced this chiclet key one with. Turning both these computers on, you'll notice there's another difference. Mine has a white phosphor or white-blue phosphor, and the later one on Earl's machine has a green screen. All the Commodore PETs that have 9-inch CRTs, whether they're the 2001 series like these two, or even I think the 3000 series, they all have exactly the same driver board. Let me kill the overhead light, and I'm going to turn off both machines at the same time so you can check out the difference in the spot. Earl's machine definitely has a spot, but it's going to match exactly the way Frank's spot was, which is there it is, it's just appearing there, sort of a slow burn. Mine takes longer to appear now and also lasts longer than this one. But of course, this monitor on Earl's machine is completely stock, unmodified, and mine has that Zener diode fix already applied to it. There's one more pretty significant difference between the green screen on Earl's monitor and the white one on mine, and it's the focus. It's pretty stark, the difference. This one is so sharp and nice looking, while the older 2001 screen, it's not terrible, but it's not nearly as crisp as on the green one. So I think my next step is going to be take the monitors off both of these computers and then remove the analog boards from both and swap them around. I want to see if Earl's analog board in my PET with my CRT makes it nice and sharp and also makes the dot behave the same with that slow burn. All right, here is my PET 2001, my PET 2001 CRT that was from my matching setup. But here is Earl's analog board from his PET 2001, the one with the slow dot and the better focus. I gave his board a quick once-over and I actually found a few cracked solder joints, which I fixed. And that actually goes with what Earl had reported, that he had some intermittent cutting out with his PET originally. So hopefully that fixes that problem. Now, taking a close look at the focus, I see absolutely no difference. This looks exactly the same as it does on my board. So clearly, the slightly out of focus nature is this CRT. It just needs a different focus voltage than the green one. And unfortunately, since this board has no adjustable focus, there's no way for me to fix that. It's still totally readable, as you can see. It's just not as crisp as I would like. But now the real test. Let's turn it off and see the spot. All right, so far nothing. Oh, there it is. Okay, it has appeared. And it's pretty faint. It is pretty faint indeed, but the timing characteristics definitely matches the way it was with the green CRT, so no real change. And it does show that this board is different. It behaves differently than the original board that was in mine. So what I'm going to do now is apply the Zener diode fix to Earl's board, and hopefully that should eliminate the spot entirely. And there's the mod installed. Let's give it a test. I'll let this warm up a moment. And will there be a spot or no spot? So I waited about 1 minute and no spot appeared. So just like for Frank, with his later PET with the green screen, the Zener diode on that resistor absolutely eliminates the spot. So that begs the question, what exactly is different about my board and this board where the Zener diode fix works here and not on mine? Let's take a look. From a PCB perspective, both of these are identical. Commodore didn't make any changes to what's going on with the PCB. And I've gone over all the other components, not every single one, but I've kind of looked at the ones that were easy to read, and I found one difference between these two PCBs. It is this cap right here on both of these. They look very similar. They're blue, they're similar sized, but their value is extremely different. So this is my board, and if I turn it, hopefully you can read that, but it's a 3.3 microfarad at 250 volts. And turning our attention to Earl's board, this is the later revision. This capacitor here is 47 microfarad at 50 volts. So with that being really the only difference, at least that I can see between these two with component values, it kind of leads me to believe that this capacitor does have something to do with the way the dot works on the later one, being slower and dimmer than the older boards, and also must have an effect on the Zener diode fix. I went ahead and asked some other people who have PETs, who also have the spot, to look at what value they have for their PETs. Now, Chuck Hutchins, who has a YouTube channel, I'll put a link to his channel down below, he has two PETs, and both of his have the fast and bright dot, just like mine. And when he took a look at his capacitor, it was also 3.3 microfarad at 250 volts, just like my older board with the fast and hot dot. And then when Frank went and checked his capacitor on his board, which has the slow and delayed dot, he's got 47 microfarad at 50 volts as well, which matches Earl's PET, which is, I lost track. This is Earl's. This one on the left is Earl's. Another slight difference is the brightness knob sticks through the back of the monitor cover on the older one like mine, and on the newer one, like this one here, it only sits just flush with the back cover. You have to use a screwdriver to adjust it. But that's not a big difference. The real difference is this capacitor. So to help prove the idea that this does affect the dot, here in my left hand is a 47 microfarad 50 volt capacitor, which I'm going to install and replace this 3.3 microfarad here. And let's see if, well, the dot should disappear because of course I have the Zener diode fix, and I have the presumption that if this does work, then if I did revert the Zener diode back to the original resistor, we would just have that slower, smaller dot. So let me swap this out. I gotta say the Hakko desoldering iron makes swapping stuff like capacitors a breeze. Really easy. It's funny, look at that size difference. Just for fun, let's take a look at this capacitor I just removed. Let's see if this tests good. Yeah, this capacitor looks good, 4.3 microfarad. Actually, the ESR is 26 ohms. That's relatively high. Maybe not for a 50 volt capacitor, but I don't know, seems a bit high, 4.3. Let's see what theta is. 85.8. That's not great. I think 90 degrees obviously is optimal. I did test this capacitor here, the one I just put on the board, and it gets over 88 degrees on theta. All right, everyone, let's turn this on. Let's see what happens. Will we get smoke? Nothing abnormal yet. All right, we have an image. Now keep in mind, this is my analog board, the one that was originally in this machine. Of course, modified with that new capacitor, has the Zener diode modification on there. I've had the PET running for about 5 minutes. Will we get a spot? Here we go. I don't know. So far, so good. Oh, wow. Oh, no, there's the spot. Unbelievable. There is the spot. So I'm thoroughly confused. Earl's board with the Zener modification did not produce a spot on my CRT, and yet my board does. So there's still a difference here. Well, about 1 hour has passed, as you can see here. I basically left this thing on, went up and had dinner. So let's see what the spot looks like now when we turn it off. I could tell you before, I didn't really show this on this video, but before I changed that capacitor with the Zener in there, if I left it this long, everything was good and hot, the dot would almost be full brightness as if it was before I did anything. So let's see what happens now. We're going to watch this in real time. So far, no dot. I mean, I'm sure it's going to appear. We know it will. There it is. All right. And that's really not that bright. So changing that capacitor made an absolute huge difference. Yeah, that's great. This dot was really, really dim now. All right, both PETs are fully back together with all their respective parts correctly installed into each of them. Of course, the Zener mod is applied to both, and on mine, of course, the capacitor has been changed. Let me turn them both off together, and let's watch for spots. So I fully expect mine to have a spot. These have been on for quite a while. And there it is. It has just appeared. And on the green 2001, no spot. And on the left, all the work has resulted in a pretty dim spot. So I guess I consider this a success, although I wish I could have eliminated it entirely. This is certainly better than it's ever been. So it's been a few days, and I want to figure out what exactly is different between my PET board and Earl's PET board, where the fix worked for him completely, and on mine it's still not working quite right. And I do have to apologize about the audio quality. I have two different microphones I use for voiceover, and they both are broken now. So I'm having to use, of all things, my webcam. So first let's talk about the capacitor that I swapped. So C22 3.3 microfarad, this is the one that on my PET was actually 3.3, but on Earl's was 47. So this was a change that Commodore made between the early PETs and the later PETs, because his is a later one with the non-chiclet keyboard. What this capacitor is used for, it's sort of a reservoir smoothing capacitor for the minus 30 volts, which is generated here. This is the flyback transformer, and while the monitor is operating, that generates the minus 30 volts, and it is an AC waveform. So this capacitor is responsible for not only smoothing it, but it also keeps that voltage rail alive once the power is cut. And what the minus 30 volts is used for is the brightness on the CRT. So this minus 30 here goes through the brightness potentiometer over to G1. This is the grid G1. And what this grid's responsibility is inside the neck of the picture tube is the cathode, which is this thing right here. It generates the electrons. And as the cathode is grounded, they want to fly towards this part of the CRT here, which is where the 10 kilovolts is the high voltage. The responsibility of G1 is to control that flow of electrons, which is why it's called the brightness, because if you turn it down, it can completely block, actually, all of the electrons from making their way to the front of the screen. The reason why changing the capacitor had an effect on the spot is because it maintained this minus 30 volts for longer once the power to the entire monitor was cut. And the longer this is at minus 30 volts, the more resistance there is right here at G1 from allowing electrons to flow past it to the front of the screen. And that's what we're trying to do here. We're trying to prevent the electrons from being shed from this cathode when it's grounded and to fly towards the front of the screen. Now the heater, which is this part right here, it's heated by 12 volts, that warms up the cathode and allows it to shed those electrons. As the cathode cools though, it loses that ability. So even as the CRT might have 10 kilovolts on it, if the cathode is not warmed up by the heater, no electrons are going to make their way to the front, which means there will be no image, no spot, none of those things. So the only time we're really concerned about is when there's still high voltage in the CRT, which happens once you turn it off because it's a big capacitor. The cathode is still warm because it takes a little while to cool off, and that G1 is getting, as it gets closer to ground, the spot is able to form. Now if we take a look at the cathode drive circuit, which we've looked at before, trying to prevent the cathode from getting to ground. This is what Frank talked about in the first video. The whole purpose of replacing R2 with a Zener diode is to keep Q2 from turning on. And that has to do with the fact that this 12 volts doesn't just disappear when you turn off the monitor. It slowly fades down to ground. So the Zener diode is making sure that Q2 is not turning on. And we know that's working because it worked on Earl's monitor. Now let's take another look at the cathode circuit here and look at where else things might be getting to ground. Well, here's a WAF here, but it's a spark gap. So those don't leak, so there's nothing to worry about there. There's this capacitor up here, C4, but that's ceramic capacitor, and those generally never leak. I mean, there's no point to even look at that. There's almost no chance of that being a problem. I also swapped out these two transistors just to test to see if they were leaking, because those are obviously connected to ground, so could be some leakage there, but it made no effect on the spot. R3 is out of play because of these diodes here, and really that leads us up here through R4 to this Zener diode. Now, normally these shouldn't leak, there wouldn't be any problem there. This is used to create a 33 volt supply off this 85 volt boost voltage, which comes in from the flyback transformer through this resistor. Frank noticed after examining the different schematics that besides that one capacitor, which we noticed was different on Earl's board, it seems that Commodore also changed the value of this resistor from 1.5K to 2.2K. And the reason that turns out is the case is because 1.5K is not enough of a current drop for this Zener diode, because it's going from 85 volts down to 33 volts. This was passing too much current in the original board design like mine. It's quite possible that over time this diode here has been so abused that it now starts to leak current. And that does coincide with the fact that as this monitor is left on for a long time, parts heat up inside, especially this diode, and that could increase its capability of leaking. That's very indicative of silicon devices. So as the final test, I have a package from DigiKey. I went ahead and I ordered some of those 33-volt Zener diodes. So I think it's time to take this thing apart again, and I'm going to swap out that diode and change that resistor. Maybe that'll fix this spot. The monitor is open, the board is out. These are the new Zeners from DigiKey. It's 33 volts, 1.3 watts. It's a Vishay brand. And I went and looked at my spare parts bin. I found this resistor here, which is 2.7K, which is close enough. And as for the parts we're going to be replacing, this is R5 right here, 1.5K. I already desoldered it on the other side, so I can pull this out, I think. And then there is the Zener, the 33 volt one we're going to be replacing. The band is towards the left. The new and the old resistor are the same size physically, so I'm assuming this one I took off another monitor is a 2-watt part. Okay, new parts are installed. There's the Zener, and there's the new resistor, 2.7K. I have the PET precariously set up. It's plugged in. I don't have the back cover on the monitor, but the PCB is mounted inside the chassis. I do have the PET plugged in. Yes, it is. Monitor cable from the computer is plugged in. Let's turn it on. Let's see if any smoke comes out. Monitor is clearly working fine with that 2.7K and the new 33 volt Zener. Let's turn it off, see if we have a spot. I'm fully expecting that there might not be a spot right now, so I need to leave this thing on for maybe an hour or so. Yeah, we're not getting any spot at all. So I'll turn this back on and then I'll leave this running for about an hour and we'll see it. Was this the actual fix? I have my fingers crossed that that poor 33 volt Zener, it just has been abused so long that it leaks. And the new one with that new resistor, so it shouldn't overwork it, should last. But we'll know for sure if I let this thing run for a while and we still have no spot.
1 hour later.
And I'm back from the grocery store. This thing has been on the whole time. I can feel lots of heat coming out the back of the monitor here, so it's good and warmed up. I've locked the focus, I've locked the exposure, and I turned off the studio light for maximum visibility of any potential spot. Here we go. Is it gonna work or are we gonna have a spot? Would you look at that? No flippin' spot. I had been working on this computer off and on for so long trying to fix this problem, and I can't believe it's finally fixed. Even though you've watched this video in just 2 quick parts, I've actually been working on the spot fix thing for this PET off and on since the beginning of 2020. So I couldn't be happier that the solution was finally found to fix the spot, which this is the 33 volt Zener in my hand here. And it just was a real journey to get there because when you're dealing with tiny leakage currents, they could be coming from various sources and it just takes quite a while to figure it out. As far as this 33 volt Zener goes, yep, dead parts bin is here, and that is gonna go in there just to remind me of how much work it was to try to find this little guy to solve this problem once and for all. Since I went in so many different directions trying to fix the spot on this thing, I wanted to give a summary of all the things that were required to fix the spot on my PET, and hopefully this translates to other people's PETs, especially these earlier boards. First, we're going to start with C22. That's the capacitor that was 3.3 microfarad on this board and 47 on the later ones. If you have one of these earlier ones, start by switching that capacitor out for the larger 47 microfarad one. The next thing to do is check the board that you have to see if R5 is a 1.5 k ohm 2-watt resistor, or if it has the 2.2 k ohm 2-watt resistor. If you have the 1.5 like I did, you need to switch that out for a 2.2 ohm or thereabouts. I put 2.7 in this thing because that's what I just had on hand. If your board was like mine and you had the R5 resistor that was 1.5 k ohms, after changing it, you're going to need to change CR7. That's the 33 volt Zener diode that has now become damaged from being overdriven with too much current the whole time when it had that 1.5K in there. You need to make sure that you change that resistor first before you change the diode, because if you put a new Zener diode in there, it might just become damaged again, so it's not going to fix the problem. You gotta change the resistor, then change the Zener diode. At this point, with those 3 components changed out on your early model monitor,
you're now ready to change out the R2 resistor with the 8.2 volt Zener and that 470 ohm resistor, as I showed how to do in part 1 of this series. If you have one of the later revision monitors that already has the 2.2K resistor and that 47 microfarad cap, just go right ahead and do the Zener mod on the R2 resistor right off the bat, and you should be good. At this point, the instructions I just talked about have worked on 3 PETs. My PET, after all the repairs, Frank's PET, which just needed the Zener diode and the resistor, and Earl Evans's PET, as I showed earlier in this part, that just also needed the Zener diode and the resistor. I shared the fix information and I sent an 8.2 volt Zener to Chuck Hutchins to try to fix his own PET monitor, and it didn't work for him. He put the Zener mod in with the resistor, and he also changed out his capacitor because his has one of the earlier revision boards just like mine, and he still had full-on bright spot. It changed it a little bit, but unlike mine where the spot was very delayed and much dimmer, his is still really, really bright. So I've given him the information on changing out that 33 volt Zener diode and that resistor, the 1.5 to the 2.2, and he's gonna have to do those mods to see if that helps him. Chuck will post his results on his channel if that 33 volt Zener fixes his monitor completely, and I'll put a link in the description to his video if it's available by the time I publish this video. Now, I brought up the fact that Chuck's monitor wasn't fixed by at least some of these mods because I wanted to illustrate the fact that when you're working with CRTs, it's an analog domain, and unlike the digital stuff in a computer where it's a lot more cut and dry, you have high and low TTL logic, 5 volts, at least on a computer like this, on the CRT, we're talking micro or milliamps or picoamps or whatever. That kind of leakage, while normally not affecting the overall operation of the monitor, clearly has an effect on it. And things like a diode that still sort of work, but clearly it wasn't working quite right, those problems are really hard to track down. We'll know soon if swapping out that 1.5K resistor and the 33 volt Zener fixes Chuck's PET. And if it does, that's a good vindication that these are a good set of fixes for the general population of PET 2001 monitors out there. But both Frank and I are very curious to know how reliable of a fix this is. So I encourage everyone who has a PET 2001, if you're good with a soldering iron and you don't mind going in there and changing a few parts, it would be really fascinating to know if these fixes work for you as well. So if you do the mod, please let me know about it in the comment section below, or send me an email or send Frank an email. That would be amazing. All right, and now I'm actually gonna wrap up this video. First, I wanna give a huge thank you to Frank for helping me with this whole series. It was really his idea and his brains that figured out the fix in the first place, and then helping with all the troubleshooting to figure out where the other problems lay with this monitor so we could actually get it fixed. If you like highly technical fixes that are way more technical than my channel, please check out Frank's channel. There's a lot of really fascinating stuff on there. He's fixed some very fascinating stuff. Next, I want to give a big thanks to Earl Evans for bringing his PET 2001 over to my house so I could do this fix on it to see if it worked. And unlike mine, it didn't require quite so much. It just needed that one Zener diode and that resistor, and his spot was totally fixed. Then finally, I want to thank Chuck Hutchins for working with me and doing some of this troubleshooting himself remotely all the way in California. And like I said, check out his channel, and also I will post a link in the description if he is able to successfully fix his PET or not, or whatever. He'll have a video on that, which I will link to in the description below. And that is actually it now. So if you like this video, I would appreciate a thumbs up. But if you didn't, you know what to do, thumbs down. Subscribe to my channel if you want. Hit that little subscribe button with the bell icon for notifications if you want to be notified when I upload new videos. And then, of course, put your comments, your questions, and your suggestions and all those things in the comment section below. I appreciate it very much when you do that. And that's going to be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.